Today we will learn section 8.7, distribution functions. We review the definition of a probability density function. The function Px is a probability density function of PDF. PDF is short for probability density function. If fraction of population for which x is between a and b is area on the graph of p between a and b and is equal to the integral of px, x from a to b. The integral of probability density function x from negative infinity to infinity is always equal to 1, and the probability density function is always non-negative for all x. So now we look at an example. Find the formulas to approximate the density function p for the US age distribution. To reflect the age distribution, use a continuous function, constant at 0.013 up to age 60, and then dropping linearly. So now this graph is the age distribution. So we want to use a continuous function to approximate the density function. This continuous function is constant at 0.013 up to age 60, and then dropping linearly. So the constant function should have the density function should have this kind of shape. So next we go to find the formula. So for the density function pt, we have pt is a constant 0.013 for t between 0 and 60. T between 0 and 60. It's a constant 0.013. For t is greater than or equal to 60, we need a linear function sloping downward. Because p is continuous, we have p60 is also equal to 0.013. Because p is a density function, we have the integral from 0 to 100 pt dt is 1. Suppose p is this red curve. So we can write this integral into two parts. It's from t from 0 to 60 plus t from 60 to 100. The first integral is easy to calculate. Right? This integral is equal to the area of this triangle. The area of the triangle. So the area of this triangle is equal to the 60 times 60 times 0.013 plus the second integral is given by the area of this triangle. We know the height of this triangle is 0.13. We don't know its base. We suppose the base is b. So the second integral can be evaluated by half times 0.013, then times b, times base b. This is equal to 1. So from here we solve for b. B is equal to 33.885. So we know b is equal to this number. So this radical will not hit 100, but this 60 plus 33.85, so it will hit 93.85. So here is 93.85. This is equal to 60 plus b is 33.85. So now we can get the slope of this line. Slope of this line. So its slope, the slope of this line is equal to, we know here its pointer is 60, 0.013, and this point, its coordinate is 93.85, 0. So slope of this line is equal to 0 minus 0.013 divided by 93 minus 85 minus 60. So this is negative 0.00038. This is the slope of this line for t between 60 and 93.85. So we have, by the point slope form, the formula of this line is given by PT. PT minus 0.013 is negative 0.00038 times t minus 60. Simplify, get PT is equal to this one. So this PT is equal to 0.0358 minus. This is for t between 60 and 93.85. So according to this way of smoothing the data, we say there is no 1 over 93.85. So I have PT is 0. PT is 0 for t greater than 93.85. So we get a formula for PT. PT is equal to a constant 0.013. This is for t greater than or equal to 0 less than 60. Then for t between 60 and 93.85, it's equal to this line. For t greater than 93.85, we have PT is 0. Now we are done.